So inside of this function, the first thing that we're gonna do, we're gonna check if the node exists, if the whole tree exists. To do that, we're just gonna say if root is not equals null. So the root is the very first structure, and if it's empty, we don't have to search for it. So let's do the else part right away. So if it's empty, we're just gonna return null. If it's not empty, we'll create a separate function for that part actually, and we'll call it the same name. The only difference, we're gonna pass a pointer to a node, and let's call it leaf again. And we're gonna create a definition of that function here. So the important thing, we have to first check if the node exists, if the node itself exists. So we're gonna say if leaf is not equals null pointer. In that case, let's display the content of the node. We're gonna display the key that the node leaf holds. So it's gonna be leaf key, and let's add a divider here. So here we're gonna display the content of the leaf. The next thing that we're gonna do, we have to check if the key value that we're looking for matches the key value of the node. If it is, that means our search function found the thing that we're looking for. So to do that, you just have to say leaf key equals key that we're looking for, found. And let's add end line here. So if the key that we're looking for didn't match with the key of the leaf, we have to check if the key is less than the key of the leaf. If it is, we have to go to the left side of the tree, because the right side is gonna be bigger, so there's no point in looking for the right side. So else, if key is less than the leaf key, we're gonna return, and it's gonna be a recursive function again. Return search key, and we're gonna pass key and leaf left. So we're gonna pass the left side of the tree, and it's gonna check that left node. If the key is less than the left side's key value, it's gonna keep going to the left. Then else if key is bigger than the leaf's key, in that case we have to go to the right side of the tree. So we're gonna return search key, and we're gonna pass key and the right side of the tree. All of this will keep checking left and right until it finds. If it finds, it will display found. But what if we couldn't find any node that has the value that we're looking for? In that case, we'll just have else statement here, and it's going to display cout not found. And we'll just return no. After we're done with this function, we have, let's call it here. So search key, and we're gonna pass our key that we're looking for and the very first node in our tree, which is root. So let's test our program. We're going to insert some values into the tree. And let's say 100. Let's copy that. Well, let's say 500, 100, 200, 3, 600, 700, 800. And let's search for some of the values. Let's say we're looking for 800. Let's search for 100. And also let's search for the value that doesn't exist. Let's say 1000. Let's run this and see if it works. Alright, so by looking at this, on the very first search function, search key, we passed 800, and our root node is 500. So since 800 is bigger than that, it went up to the right side, and it kept going to the right side of the tree, and it found it. And when we passed 100, the 100 is less than 500, so it went to the left side of the left side of the tree, and it found it. And when we looked for 200, it went to the left side of the 500, which is 100, and it went to the right side of the 100 because 200 is bigger than 100, and it found it. Then when we looked for 1000, since 1000 is bigger than 500, it kept going to the right side of the node looking for the value. When it reached the highest, it stopped because there's the left and right side of the 800 is empty. So as you can see, in total we have seven numbers. If you had a linear array, just a regular array, and if you're looking for, let's say, 800, you will have to iterate through each node, like 1, 2, 3, and to find 800, you will have to iterate 7 times to find it. But since we sorted the whole thing and we have a tree, all we had to do is it took 4 iterations for the program to find the node with that key value. So this is like a small example. If you have a huge database, this is gonna make your search function very fast, and it is important if you have a big databases. And the last thing that we can do, let's create a function that destroys the tree. So we're gonna call it void destroy tree, and we want to make this one recursive as well. So we don't want to have memory leak, so we have to go to each node individually and delete it from the memory. So we're gonna have another copy of this function, and we're gonna pass node leaf. So we're gonna go to each node, and let's create a definition here. Destroy tree, and we're just gonna pass destroy tree. We're just gonna pass our root, the very beginning of our tree. So for the second destroy tree function, we accepted the very first node, which is root. So what we have to do, we have to check if leaf is not empty. In that case, we have to call the destroy tree function for the both left and right side of the tree. So it's going to be left leaf, and it's going to be the left side of the tree. And we're going to do the same for the right side as well. And in the end, when we're done deleting all the branches of the tree, we're just going to delete the root. Let's call the destroy tree function our main. let's run this. That's it. It works. Alright, so it seems like it works just fine. Thank you very much for watching.